Hey yo, it's your boy PhisyIzzy back at it again with another physics video where physics is fun! Today we're going to be testing out a roller coaster because that's physics. How are we going to do it? With those Hot Wheels tracks and our trusty number 6 screen pool ball. And so, here's the plan, here's the layout, here's what we're thinking, right? We're going to want to start it up here with our green trusty pool ball and our Hot Wheels track. We're going to have it come down over here around this area. We're going to have a loop-de-loop. We're going to go shoo, and it's going to come over here, go over a little hump, right? Because that's always cool, you know? And then we're going to go swerve a little bit over here through the pillar of the railing. Come over here, around this pillar, and then it's going to go over there, and it'll have some fun over there. You'll see, you'll see.
Now, the concept of the roller coaster is pretty simple. We have a hill, into the loop, and into the bump. So this hill is around 0.81 meters high. The loop is 0.22 meters. And this bump here is 0.12 meters. Alright, so up here at the top of the hill is where there's going to be the most potential energy. Right there. And at the bottom of the hill, right here, so there's going to be the most kinetic energy. Now, on this hill, the entirety of the potential energy is going to be transferred to kinetic energy, and since energy is always conserved, the max potential energy is equal to the max kinetic energy. So on the hill, the potential energy is turned into kinetic energy. That. Now, as we get into this loop here, the kinetic energy is going to start turning back into potential energy, but since the loop is not as high as the top of the hill, it's not going to reach maximum potential energy. Like that. And then as it goes down the other side of the loop, potential energy is going to be turned back into kinetic energy until it reaches the bump, in which it's going to turn back into potential energy, and then back into kinetic energy on the other side of the hill. Alright, that guy was taking way too long, so let's speed things up a bit. Now we need to find the kinetic and potential energy at a point which we chose to be the top of the hill. Now, using the height of the hill, the mass of the ball, and a few simple measurements of velocity, we determined that the kinetic energy was 0.014 joules, and the potential was 0.18 joules, giving a total mechanical energy of 0.1948 joules, like this. And now we need the velocity and acceleration from the bottom of the loop to the top of the hill. After a few measurements, we found that the average velocity of the ball was 0.823 meters per second, and the acceleration was negative 1.4686 meters per second squared, which makes sense because the ball is slowing down, like this. And now, back to the video. And that's all the math.
Alright, Fizzers, we just finished building this roller coaster, and I don't know about you, but I cannot wait to show you guys this roller coaster. This is gonna be sick. Alright, let's get going. Alright, Fizzers, it's time to see if physics really does work, and to see if this roller coaster can take this ball all the way to the end. You ready? Because I sure am. Let's go! Alright, Fizzers, that was another episode of PhisyIzzy. You guys saw how that roller coaster worked. It took the ball all the way to bottom. You got anything to say?
Yeah, we saw that the potential energy turned into kinetic energy as it went down the ramp, but the total mechanical energy remained the same because energy is conserved.
That was just what I was gonna say, just what I was thinking, and you know what? That's a great way to put it. Alright. Thank you so much for tuning in to another episode of PhisyIzzy, and don't forget to like, subscribe, and comment your favorite theme park horror movie. Alright, let's go! See you in the next one! Woo! Physics is fun!